the async keyword always return a promise. Second, if the return value from inside an async function is not a promise, it'll be wrapped in one that resolves immediately. Third, the await keyword will pause the execution of an async function until a promise is complete. Fourth, await will do one of two things with the result of a promise. It'll either give you the result from a fulfilled promise or throw an exception from a rejected promise. Fifth and last, await is only valid for use inside an async function. I'm sure you've noticed the async keyword always return a promise. Second, if the return value from inside an async function is not a promise, it'll be wrapped in one that resolves immediately. Third, the await keyword will pause the execution of an async function until a promise is complete. Fourth, await will do one of two things with the result of a promise. It'll either give you the result from a fulfilled promise or throw an exception from a rejected promise. Fifth and last, await is only valid for use inside an async function. I'm sure you've noticed. Then it exports a function called hello world. It's defined using the functions identifier from above, and it's an HTTP type function. HTTP functions let you respond to incoming web requests. When a web request occurs, the function triggers with a request and a response parameter. These actually come from a node module called Express. So if you already know Express, you'll be right at home here. Then, in the body of this function, I'm going to send a string back to the client. That response ends the function. And that's all there is to it. It's important to know that the Cloud Functions runtime actually requires JavaScript code to run. But since I'm using TypeScript, it has to be compiled into JavaScript first before deployment. The Firebase CLI will do that automatically when you run the deploy command. The default configuration takes all the TypeScript from the source folder and compiles it to JavaScript in the lib folder next to it. You don't need anything from the lib folder checked into your source control, so you should add it to your gitignore as well. Okay, let's deploy this code. Back at the command line, I can use the Firebase CLI to deploy like this. You can see that the TypeScript is compiled into JavaScript, and that's being sent to Cloud Functions. When the command finishes, it gives me a link to the console for my project, and also the URL for the HTTP function that I just deployed. If I copy that URL, paste it into my browser, it'll invoke the function, and I see the response that it sent. Now, I'll go back to the code, change the welcome message, and also add a console log, which I'll find later in the Firebase console. Then I'll deploy the function again, just like last time, and reload the browser. And now I see the new message. But what about that console log? To see where that went, I can go to the Firebase console for my project, select Functions on the left, and choose to view logs for my Hello World function. And here, I can see the log message. You should use console logs like this to help test and debug your functions. Here's a new Cloud Functions project configured to use TypeScript. First, I'll create a new TypeScript file to play around with, and I'll create a plain function in here that returns a string. When I hover the mouse over the function name, the TypeScript compiler is correctly inferring that this function returns a string, even if I didn't declare it specifically. I can be explicit about the return type by adding it to the function declaration. The function works the same with or without it. Now, if I put the async keyword in front of this function, the TypeScript compiler complains about the return type. It's saying that async functions must return a promise. If I get rid of the return type, then hover the mouse over the function name again, I see the compiler has now inferred that this function returns a promise that contains a string, and there's no compiler errors. The async function you see here returns a promise to the caller, even though internally it returns a string. I can manually wrap the string into a promise with the promise.resolve function. This actually behaves exactly the same way as before, except now I'm being explicit about the promise wrapper. And if I want to be perfectly clear, I can also formally declare that this function returns a promise that contains a string. And it doesn't matter if the internal return value is actually a promise. Love you, TypeScript. Here's the same async function as before that returns a promise that's immediately fulfilled with the string value. Now I'll add another function called getRank that returns a promise that's immediately fulfilled with the number 1. If I want to call getRank from within my function, I can do that here and capture its promise in a constant. VS Code shows that the type of the constant is a promise that contains a number. And if I want to get a hold of the value fulfilled by the promise, all I have to do is use await before that promise, then assign another const to the value it returns. Now VS Code is showing us here that rank is a number, which is automatically unwrapped from the promise. Then I can work with that number without having to call then on the promise like I would without async await. It turns out that the constant rank promise is actually unnecessary, so I'll just get rid of it and use await on the results of getRank directly. This style is common, and it's similar to chaining promises that I showed in a previous video. Here I'm adding a try-catch block around the use of await to trap any rejected promises during getRank, then return a different string in case that happened. If getRank returns a rejected promise, the catch block will get executed with the value from the rejected promise. For most APIs, this will be an error object, but here it's a string. Now, if I modify getRank to return a rejected promise like this, the string returned from my function would indicate an error. Don't worry, Firebase, you'll always be number one to me. There's just one final thing you need to know about async await. The await keyword is only valid to use within the body of an async function. Anything else is a compiler error. Let's see that. If I remove the async keyword from my function, you can see that VS Code immediately marks the await keyword with an error. If I hover over it, I get a message from the TypeScript compiler saying that await is only allowed within an async function. The async keyword always returns a promise. Second, if the return value from inside an async function is not a promise, it'll be wrapped in one that resolves immediately. Third, the await keyword will pause the execution of an async function until a promise is complete. Fourth, await will do one of two things with the result of a promise. It'll either give you the result from a fulfilled promise or throw an exception from a rejected promise. Fifth and last, await is only valid for use inside an async function. I'm sure you've noticed current weather conditions for the city of Boston that's stored in a document in Firestore. It uses the Firebase admin SDK to access Firestore. It creates a reference to a document in the city's weather collection for the city of Boston. Then it uses the get method on that reference. Remember that get is asynchronous and returns a promise that will become fulfilled when the document snapshot is available. To get a hold of that, it calls the then method on that promise and passes an anonymous callback function which receives the snapshot. The function pulls the data out of the snapshot and sends it to the caller as JSON. Or, if there's an error, the chained catch callback will be invoked. The function passed to catch receives the error object, and that's what's used to send an HTTP error response to the caller. This one is easy to refactor to use async await. First, I need to mark this entire anonymous function passed to onRequest as async. This will let me use await inside of it. Then I'll create an empty try-catch. I'll move the document fetch into it, and I'll use the await keyword to pause my async function until the snapshot is ready. To get that snapshot, all I have to do is use the await keyword before the promise returned by get. Await unwraps the snapshot from the promise, and I can assign it to a constant. Now, I'll move the rest of the code that deals with the snapshot into the try block, and I'll move the code from the old catch callback into the new catch block. And after removing some old code, the refactoring is done. This function was pretty straightforward to refactor to use async await. In my opinion, the code is easier to read now. With async await, there's fewer functions and parentheses to deal with. Now, let's take a look at another function from a prior video. This is a Firestore trigger that fires whenever the Boston City weather document is updated with new weather conditions. When that happens, it takes the updated contents of the document, uses it to build a payload for a notification, and sends it to a Firebase Cloud messaging topic for mobile applications to receive. The important thing to remember here is that Firestore triggers need to return a promise to indicate when all the async work is complete. You can see that send to topic returns a promise that becomes fulfilled when the message is sent, and that promise is returned from the function here. So what can we do to refactor this function to use async await? Well, there's a lot going on in this HTTP function, so I'll go over it real quick. It gets a document from Firestore that has a list of cities in the greater Boston area. For each city in that list, it gets another document that contains the current weather conditions in that city. The promise for each document fetch is collected into an array, and promise.all is used to create a new promise that's fulfilled after all the others are fulfilled. An array of snapshots of documents is delivered to the next then callback, where their data is collected into another array and sent to the client as JSON. To refactor this to use async await, I'll do like before and mark the function async, then create an empty try-catch. I'll move the first document get into the try block and use await to unwrap the snapshot from the promise. Then I'll move the rest of the code from the first then callback. Now I've got all these promises collected here, and the call to promise.all to combine them into a stringle promise. Let's talk about that for a moment. Instead of returning that promise to the next then callback, I'll use await here again and capture the resulting array of snapshots in a const. Then I'll move the rest of the code into the try block. And lastly, I'll move the code from the catch callback into the new catch block, and that's it.